Okay, welcome back again. So I'm going to continue with the discussion of this model by Pietro Pareto. So let me go one slide back. So again, we know how the firm size will change. Again, firm size is defined by the gross cash flow divided by average quality, right? We know how output per worker changes, and we also know how consumption output ratio changes, right? So this is your earlier equation. Then it also depends on the quality and quality growth rate and product number, the growth rate of the product varieties. Okay. Now, okay, so the question is this. For the linearity, critique, and robustness, right? So what is the lower bound on kappa that ensures non-decreasing growth, right? So we want to ensure that growth will be balanced, right? And so there's a fixed growth rate in the very long run. So output per worker will exhibit that growth. And also we have to consider what is the upper bound, right? So we don't know what kappa is. So kappa is a positive number that is at least equal to 1. But what is the upper bound, right? Upper bound is important because we also want to eliminate explosive growth paths, right? Because if average quality is going larger and larger, firm size can decrease, and that creates instabilities. So what we find is this: the lower bound will be equal to 1. Because at least the firm size will be non-decreasing in Z. So if you go back to this, definition of gross cash flow, you see that it depends on Z, and kappa minus 1 is important. So if kappa is less than 1, then firm size will be decreasing quality, and that is not realistic, right? Because in the real world, we observe higher quality intermediate products is produced in bigger firms. All right. So if you look at the most innovative sectors and the firms in modern economies, there is a positive relationship between the market sizes. So for instance, Apple, Google, right? So these are the firms, these are the IT firms that have the largest gross cash flow and that offer the highest quality products. And also there must be an upper bound because the stability of the balanced growth path requires that, right? So this is endogenously determined, so that upper bound, it is in the paper. I'm not going to go into that detail, but there must be, so it cannot go to positive infinity. All right. So it is like a Goldilocks condition, right? So it must not be below unity for growth to continue, and it must not to be a very, very, very large number, because we want this model to have a stable long run balanced growth path. Now, to analyze the model, we analyze this balanced growth path, right? So we define the balanced growth of consumption output ratio. So we will look at a balanced growth equilibrium where consumption output ratio is fixed. This is C, right? And also we want to understand this equilibrium in an equilibrium in which firm size will also firm size is also fixed, right? So once we impose these conditions of balanced growth path, what we have is this, right? So the growth rate of the number of products will have a particular relationship with the quality growth rate and the interest rate, and again, it will have a particular relationship governed by this equation as well, right? Because we have two equations here, and these two equations imply these results. Okay. Now, one important think about the equilibrium of this economy is this. So there is a threshold market size. Okay. So if the firms does not have a sufficiently large market, okay, in terms of quality adjusted gross cash flow, X, then they do not innovate, okay? So there must be an equilibrium, therefore, that may imply a non-innovating economy where there are firms and they find optimal to not to innovate in R&D, okay? Why is that important? Well, because from this you can write down an a model that explains stagnation as well, right? If there is no innovation on the vertical dimension, then output per worker will remain same. In fact, when there's firm growth, that might sometimes imply decreasing output per worker growth rate. So what is that? What is that threshold? Well, xz is that threshold, and it depends on beta, phi, and alpha. Okay, so you can actually solve for it. That is one important element. And okay, so where are these figures? So okay, let me find these figures now. For some reason, I lost them. Okay, very nice. So let me find the figures. Okay, this one is there. What about this? Okay, and this one. Okay. So do you see it now? There's a figure.
Yes.
Okay. So in this figure, you see the quality growth rate on the vertical axis, okay, and horizontal innovation growth rate X. Sorry, this is the market size effect. I'm sorry. So the market size on the horizontal axis and quality growth rate on the vertical axis. So if you look at the this, where is that? Okay, I don't have it in my slides, but basically equilibrium requires these two equations to intersect. So what are these curves? The first curve is the general equilibrium effect, right? So it goes like this. So let me use my annotation. So one of them is this, the blue one. Okay, and the other is this, the red one. Okay, so the red one is the no arbitrage condition. Okay, so this is no arbitrage condition, and the blue one is the general equilibrium condition that clears the asset market-based threat. So the funds are allocated so that there is the general equilibrium in the economy. Now, if xz is less than that, right? So this is the threshold, remember. Then z is equal to 0, right? Z is equal to 0. And above this level, there is only one equilibrium, as you see, right? And in that growth equilibrium, market size is fixed and the growth rate is also fixed. Okay, and if you actually solve it, you find this result. Okay, so you see how complex the growth path, right? So the growth rate of average quality depends on how many parameters? 1, 2, 3, 4, 5, 6, 7. Is that correct? 7 parameters. So 7 different parameters that are all assumed to be fixed, by the way, or 7 or 8, maybe 8. I'm not counting.
Yes, 8.
8, right? There's kappa as well. Yes.
Yes.
So 8 different parameters that are about preferences, technologies, market structures, the cost structures. All of these parameters will affect the long run growth rate of the economy. And also these parameters, I think they're the same set, they also affect the market size in the steady state. Okay, and along this steady state, consumption is going to grow, output is going to grow, average quality is going to grow, the number of firms is going to grow, right? But all in a balanced growth path, right? These growth rates are going to be balanced depending on the parameters. And finally, this figure shows you the CX figure, right? So what is the dynamics? So as you see, so you can actually draw these things as well. For instance, this area is not feasible, right? So given a market size, a consumption output ratio larger than some level is not feasible in terms of resource allocation. Okay, and there is that level after innovation starts, right? If the market size is larger than X of Z, once innovation starts, then there is that maximum consumption output ratio. Okay, again, all of this can be solved by pen and paper. That's the beautiful part of this model. And once you have these figures as well, so the change in X dot and the change in C dot, if you draw them, you find that there is this steady state, which is a settle point, right? And once again, how do we know we're going to converge to that settle path? Well, because rational economic agents will jump on the settle path, right? By choosing a consumption level that is exactly on the settle path. In the long run, under full information, we converge to this equilibrium. And again, in this equilibrium, there is a fixed market size and the fixed consumption output ratio. Okay. So this system is again the system you see over here. Okay. This one. So you know what R of X is, what Z of X is. These are determined above, and then you can draw these curves as a function of X. Okay. And depending on, of course, I mean, one thing you should also realize is that curves have different shapes below and above the threshold, right? Because Z of X change. Z of X change. That's the notion. That's all I'm gonna say about this model. There's maybe one more thing I should add. Yes. So in steady state, that's important. The model's engine of growth is product quality. Product variety plays a supporting role, crucial for the stability of the system, soaking up the growth of the size of the market to stabilize quality adjusted profitability, and thereby the economy's interest rate, right? How? Well, again, you should go back to this. As you see, if N is not here, right? If there is no product innovation, then there is no stable evolution of the market size, right? Market size will always grow with the same number of products. For this reason, product innovation sterilizes another type of scale effect, right? To create a stable market size in the long run when population grows and average quality grows, okay? And then the overall picture will be more realistic, right? Why? Because we observe in the real economies, we observe the increase in the number of products. Production processes becomes more complicated with the introduction of new intermediate inputs, and these firms are becoming more productive by increasing the R&D spendings and therefore increasing by making some R&D spendings and therefore increasing the average quality of their products or intermediate inputs. Okay, so that's how this is one way to understand such modern economies. And the model is actually more general than this because there is also a threshold for product innovation, right? So there's another paper by Pareto that studies the long run, very long run evolution of output per worker and technological progress. And in that paper, he actually uses a similar model to discuss the quality thresholds and also product variety thresholds. Okay, so market size is also important in general for the product innovation as well. And you must understand why, right? Because market size is affecting the profitability, and profitability is also affecting the return on product innovation, as you see here. Right? So this is the return on product innovation, and product innovation depends on profitability here as well. And again, be careful with this typo. This must be beta ZT, right? Not XT. It will be ZT. Okay, that's all I'm gonna say about robust endogenous growth. You're gonna have one assignment that you're gonna solve with pen and paper. You're gonna find some analytical solutions of the second generation Schumpeterian model. Now we have time. If you have questions, comments, we can spare some time for that. Okay. So then we're gonna meet on Wednesday, and we're gonna talk about automation and the test-based framework. There are papers I already listed in the syllabus, so maybe you can take a look at the papers, and then in the Wednesday on Wednesday, we're gonna have our meeting right on time at 9 a.m. Okay.
Okay, thank you.
Okay,
Alright.
thank you.
Alright.
Hocam,
Yes, go ahead.
çarşamba günkü dersin dosyasını da ekler misiniz hocam? Dersten önce bakabiliriz belki.
You mean the papers?
Yes.
Okay, I can put the links to the papers.
Thank you.
All right, bye-bye.